Imagine having to repeat a task multiple times, like greeting every student in a classroom. This repetition can be tedious.
In programming, we encounter similar situations. Loops come to the rescue. They allow us to execute a block of code repeatedly. This repetition continues until a certain condition is met. This makes our programs efficient and powerful.
Loops are fundamental in programming. They help automate repetitive tasks. This could be reading data from a file or processing elements in a list. Without loops, our code would be long and unmanageable. Loops bring elegance and efficiency to our programs.
The for loop is like a well-structured schedule. Let's say you want to print numbers from 1 to 5. The for loop is perfect for this task. It allows you to repeat a block of code a specific number of times, making it incredibly efficient for tasks that require repetition.
It has a specific syntax that you need to follow to make it work correctly. C++ for initialization, condition, increment, so code to be executed repeatedly.
Initialization. We start by initializing a counter variable. This is usually set to the starting value of our loop. In our example, we would initialize a variable I to 1. This sets the stage for our loop to begin.
Condition. This is the gatekeeper of the loop. As long as this condition is true, the loop continues. In our case, the condition is I less than or equal to 5. The loop runs as long as I is less than or equal to 5. This ensures that the loop will execute exactly 5 times.
Increment. After each iteration, we need to update our counter variable. This is where the increment or decrement comes in. We increase I by 1 after each iteration. This step is crucial as it moves the loop towards its termination.
Here's the code to print numbers from 1 to 5. Notice how each part of the loop works together to achieve the desired outcome. C++ for int e equals 1, I e5, I++ plus count I 5.
This loop will print 1, 2, 3, 4, 5. And just like that, with a few lines of code, we've efficiently printed the numbers from 1 to 5. The for loop is a powerful tool in any programmer's toolkit.
The while loop is like a persistent question asker. It keeps executing a block of code as long as a condition remains true. Think of it like waiting for a friend. You keep checking if they've arrived. Once they arrive, you stop waiting.
C+ while condition is a code to be executed repeatedly.
The condition is evaluated before each iteration. If it's true, the code inside the loop executes. If it's false, the loop terminates.
Let's write a while loop to find the first multiple of 7 greater than 100. C++ int num equals 100, while num %7. So, num++ could num output 105.
In this example, the loop continues as long as num is not divisible by 7. Once a multiple of 7 is found, the loop stops.
The do-while loop is a close relative of the while loop, often used in programming to ensure that a block of code runs at least once. The key difference is that the do-while loop guarantees at least one execution of the code block, regardless of whether the condition is true or false initially.
C++ do, code to be executed repeatedly, while condition.
Notice that the condition is checked after the code block, which is a crucial aspect of the do-while loop. This ensures that the code inside the loop runs at least once, providing a safety net for initial execution.
Let's say we want to get user input until a valid number between 1 and 10 is entered. This is a common scenario where a do-while loop is particularly useful. C++ int num do quote. Enter a number between 1 and 10. Sin num ing while num 1 sum num 10.
This loop will keep asking for input until the user enters a number within the desired range, ensuring that the program behaves as expected. The code inside the loop executes at least once, even if the initial input is invalid, making it a reliable choice for input validation and similar tasks.
Section 5. Nested loops. Loops within loops. In this section, we will delve into the concept of nested loops, a fundamental aspect of programming that allows for more complex and efficient code structures.
Imagine drawing a pattern of stars. You might draw multiple rows of stars. Each row itself contains multiple stars. This is similar to nested loops, loops within loops. Nested loops are essential when you need to perform repetitive tasks within another repetitive task. For instance, creating a grid or matrix, or even generating complex patterns.
A nested loop is simply a loop inside another loop. The outer loop controls the overall iteration. The inner loop performs a specific task within each iteration of the outer loop. This structure allows for intricate operations to be carried out efficiently, such as processing multi-dimensional arrays or handling nested data structures.
Let's create a program to print a multiplication table. In C++, it looks like this. Nested loops are particularly useful in scenarios where you need to handle data in a tabular format, such as generating a multiplication table.
For int I equals 1, I equals 10, I++, for int j equals 1, j equals 10, j++, count, I, j, or t, count, endl. This code snippet demonstrates how nested loops can be used to generate a multiplication table, with the outer loop iterating through the rows and the inner loop handling the columns.
The outer loop iterates from 1 to 10, representing the rows. The inner loop, for each row, calculates and prints the product of I and j. This creates our multiplication table. By using nested loops, we can efficiently generate and display the entire table with minimal code.
Nested loops are powerful for handling multidimensional data. Think of images, tables, or any data that can be represented in a grid-like format. They are indispensable in scenarios where data needs to be processed in layers or levels, making them a crucial tool in a programmer's toolkit.
Section 6, breaking the cycle, the break statement. Imagine reading a list of instructions. You come across a statement. If you encounter the word stop, discontinue reading. The break statement in programming is similar. It allows us to exit a loop prematurely, even if the loop condition is still true. Let's modify our previous example of finding the first multiple of 7 greater than 100 C++ int num equals sign 100. While true, num++, if num%7 equals sign 0, break, count num / output 105. In this case, we have an infinite while loop. Condition is always true. However, the break statement terminates the loop as soon as a multiple of 7 is found.
Section 7. Skipping ahead, the continue statement. Imagine you are sorting a basket of fruits. You are instructed to skip over any apples. The continue statement in programming is like this instruction. It allows us to skip the current iteration of a loop and move on to the next one. Let's print all even numbers from 1 to 10, skipping the number 6 C++ 4. Int I equals sign 1, I equals sign 10, I++. If I equals sign 6, continue. If I%2 equals sign 0, count I / output 24810. The continue statement skips the iteration where I is 6, preventing it from being printed.
Section 8. Practical example. Summing an array. Let's combine our knowledge of loops and arrays to solve a practical problem. Summing all elements in an array. C++ int numbers is odd 2, 4, 6, 8, 10 value. Int sum equals 0. Int array size equals size of numbers. Size of numbers, sizum. 4. Int I is 0. I array size, I++. Sum plus Salo's numbers, I. Count. Sum of array elements. Sum. Endl. In this example, we first initialize a variable sum to 0. Then, we use a for loop to iterate through each element of the array numbers. In each iteration, we add the value of the current element to the sum variable. Finally, we print the calculated sum. This example demonstrates how loops can be used to efficiently process data stored in arrays, a common task in many programming scenarios.
Section 9. Conclusion loops as building blocks. Loops are fundamental building blocks in programming. They provide a way to execute code repeatedly, automating tasks and making our programs more efficient. We explored different types of loops: for, while, and do while. We also learned how to control loop flow using break and continue statements. Understanding loops is crucial for any C++ programmer. They are essential for working with data structures, processing input, and many other programming tasks. As you progress in your programming journey, you'll find that loops are your constant companions, helping you write elegant and powerful code.